Yeah. So last class we have seen the logic gates. We have started to see about this logic gates. What are the logic gates available? We have seen about the AND gate, OR gate, inverter, buffer. Okay, and now we'll see the logic gates called as NAND, NOR, exclusive OR. Okay, and exclusive NOR. So these are the four logic gates remaining here. So we'll start with the NAND gate here. So NAND is nothing but the inversion of AND gate. So you can see the diagram, logic diagram here. So when use this logic diagram, so there's a bubble after the AND gate here, so which is nothing but the inversion of this AND gate here. Okay, and the truth table is also inversion of the AND gate. So 0 0, 0 1, 1 0, and 1 1. Okay, so this is the inversion of NAND gate here, AND gate here. So we'll get the opposite values here. Okay, and the equation is given like f is equal to xy whole bar. Okay, because it is a whole bar is nothing but the complement of the AND gate here. So for x AND gate it is xy here, and it is whole bar for the NAND gate here. Okay, so this is the equation, this is the truth table, and this is the symbol of this NAND gate. Okay, and we'll draw few conclusions here. So few major conclusions. Okay, you are clear with the truth table, right? So it is the inversion of AND gate. Okay, the major conclusions are, so check these two values. So 0 0, 1 1. So what happened there? So first conclusion is, so check the value there. So there is, so check the values of 0 0 and check the values of 1 1. So what is output there? What is output there? Same వచ్చింది అక్కడ xy 0 0 ఉంది ఇక్కడ xy 1 1 వచ్చినప్పుడు ఏం అవుట్పుట్ వచ్చింది? What is the value of f?
Inversion.
Inversion, yeah. When two inputs of NAND gate are similar, AND gates function as inverter. Okay, AND gate functions as inverter. So if I want to use an inverter, so I can use an AND gate where two inputs are equal. So I can tie these two inputs together. Okay, so I can tie the two inputs together. So x and y are equal. So if I tie this two together, then this can be this can work as an inverter here. Okay, so this can work as an inverter. Okay, so that is one of the properties of NAND gate here. So any other properties? Any other property? Any other property for this NAND gate? If two inputs NAND gate is high, the output is low. Just extension of this. Okay. Or if we can't draw many things from this one here. Okay, when two inputs of NAND gate is 0, the output is 1. No, so this is the case here. So if I want the output of NAND gate as low, so two inputs, all the inputs, what are the inputs we have? So those all the inputs should be equal to 1. Okay, and NAND gate can be used as an inverter. Okay, NAND gate can be used as inverter when the two inputs are equal here. Okay, so actually we can implement any kind of gates using the NAND gates. So that we can see later. So how to implement other kinds of NAND gates. So if here we have seen the inversion here, we can use the inverter. So I can use an inverter here so that I can implement I mean, when the two inputs are tied together, this NAND gate functions as an inverter. Okay, this NAND gate functions as an inverter. So if I connect this to another inverter, it will function as an AND gate. It will function as an AND gate. So there are many ways to convert this NAND gate, to extract the NAND gate with different functionalities. So we'll see that in the later classes. So NAND gate and NOR gates are called as universal gates because we can extract any functionality with the help of NAND gates here. Okay. So what is an AND gate in general? So NAND gate is an inversion of AND operation. So whatever the truth table we have in the NAND gate, so that will be inverted here. So the inversion of NAND gate will give the inversion of AND gate will give the NAND gate. Clear?
Yes, sir.
Okay.
Yes, sir.
Yeah. Any doubts?
Yes, sir.
So any doubts in this NAND gate function? Because we will go in detail in the future classes. So we'll go in detail how to implement each and every functions using NAND gates. So just know the basic of NAND gate right now. Clear?
Yes, sir.
Okay.
Yeah, sir.
Next we'll see the NOR gate. So it is opposite of OR gate. Okay, so OR gate, inversion of OR gate. So we'll get the NOR gate here. So check the symbols. So symbols are very important. So inversion bubble is there, so that will give the inversion symbol here. Okay, and so inversion of OR gate operation. So OR gate ఏవైతే ఉన్నాయో, so that is operation we'll get here. Okay, so in OR gate, so we can draw this conclusion. If any one of the inputs of NOR gate is 1, output is 0. Again, you can see that from the truth table. Okay, and if all the inputs of NOR gate is are 0, then output is 1. That is high. Okay. So tell me, using De Morgan's theorems, what will be the output of this equation? So f is equal to x plus y whole bar and number. So what is, using De Morgan's theorem? So what is the output of this one? So x plus y whole bar and time right, using De Morgan's law.
X bar into y bar.
X bar into y bar. So using De Morgan's law. So xy whole bar is nothing but x bar plus y bar. For NOR gate, this will be the output, or I can write like this only, x plus y whole bar. So that is equal to x bar into y bar. So and this is the conclusion we can draw from this. If any one of the inputs of NOR gate is equal to 1, the output is equal to 0. If any one of the inputs of all the inputs of NOR gates are 0, so then output is equal to 1. Okay, then output is equal to 1. So that is the NOR gate function. Yeah, it is opposite of OR gate. It is opposite of OR gate. So it is an inversion of OR gate. Right? Clear with this?
Yes, sir.
Okay.
Yes, sir.
Okay. Next we'll see the XOR gate. So already we have seen the XOR properties. So what is XOR property? Exclusive property చూసాం కదా. So what is exclusive property? So exclusive in terms of is చూసాం ఏది దీంట్లో in Hamming codes. We have seen the exclusive property. So what is the meaning of exclusive property? So exclusive property అంటే ఏంటి? forgot. So having quotes. So what is exclusive property? So what is XOR property? I need an answer. So tell me the exclusive property.
Sir,
చెప్పండి మా ఎవరో చెప్తున్నారు. When? So what is XOR operation between 0, 0?
output is 0, sir.
So when we have similar inputs, the output is 0. When we have dissimilar inputs, the output is equal to 1.
1, sir.
1.
Yeah. XOR operation between two similar
Input
inputs. So the output is
low, sir.
0. Okay. So that is like so 0 XOR 0, so 1 XOR 1, the output will be low. Okay, and XOR operation between two dissimilar inputs.
High, sir.
Operation between two dissimilar inputs, output is high. Okay, and there is a symbol for XOR. You can see here. So plus with a circle. So that is a symbol for XOR. Okay. So that will be the symbol for the XOR operation. Clear?
Yes, sir.
Yes, sir.
Now I'll tell you one more property here. So if I have X here, and if I want to perform XOR operation with 0, okay, so what is the result? And X XOR of 1, so what will be the result? So so what is the value of output of this one, and what is the output of this one?
Sir, first one is 0, sir.
0. Sure. So check the truth table. So truth table check again. Sorry.
X, sir, first one.
First one is X. Very good. Next. X XOR of 1. So check the truth table. So
X bar.
this is X here. Yeah, that is X bar. Okay, so that will be equal to X bar. So remember these points. Okay, so x XOR of 0 is equal to x and x XOR of 1 is equal to x bar. So you may substitute in this equation, or so what we'll get here, you can check the truth table here. Okay, so check this truth table. So you see here the value of this is x here, the column, and this is y. So I'll assume y as a 0 or 1. Okay, so check the value of x here. So I don't assume any value of x here. Okay, so XOR operation with 0. 0 అంటే y ఎక్కడ ఉన్నాయో చెక్ చేసుకోండి ఒకసారి. So this is XOR operation with 0, and here this one is. Okay, so if I perform x XOR of 0, so I got a 0 here, and if I performed x XOR of 0 here, I got a 1 here. Okay, and check the value of values here. So here it is 0, here it is 1. So both are equal to x here. Both are equal to x. So when I perform x XOR of 0, okay, the output is equal to x here. Okay, so when I perform x XOR of 1, okay, so check these two cases here. So check these two cases. So what are those two cases? So this one and this one, where x is performed XOR operation with 1 here. Okay, so I perform XOR operation of these two. So what I got here? So I got a 1, which is inversion of x here, and I got a 0 here, which is inversion of x here. So I'll get x bar here. Okay, so x XOR of 1. So if I perform one of the inputs of XOR is equal to 1, I'll get a x bar as output. Okay, if one of the inputs of x is equal to 0, the input is output here. Okay, so if I keep this as 1 here, so y is 1, so f is equal to x bar. If y is equal to 0, it is equal to x. Okay, it is equal to x here. Getting my point?
Yes, sir.
Okay, so x XOR of 0 and x XOR of 1. X XOR of 0 is x here, and x XOR of 1 is x bar. X XOR of 1 is x bar, and this is the equation for exclusive OR gate. So f is equal to xy bar plus x bar y, and that is equal to x exclusive OR of y. So xy bar plus x bar y ante it is exclusive OR operation. Okay, so I'll let you know how this equation ఎలా వచ్చిందని చెప్తా మీకు. Okay, so అన్ని equations ఎలా వస్తాయో based on the truth table will derive the equations also. I'll let you know. Okay, so first of all, remember this equation: f is equal to xy bar plus x bar y. So that is nothing but x exclusive OR of y. So this total operation is exclusive OR operation, that is x exclusive OR of y.
Okay, sir.
Okay, so that is exclusive OR operation. Okay, and if I do the inversion of this, I'll get the x naught. So just what I'll do here is just place a bubble here, and these values will be inverted. So 1 0 0 1. For similar inputs, the output is 1. For dissimilar inputs, the output is 0. So that is the property of x naught, that is exclusive NOR. Okay, so we'll check that. So 1 minute. Please wait for a minute. Long. Madam చెప్పండి. క్లాస్ చెప్తున్నా 20 minutes అయిపోతుంది. చెప్పండి పర్లేదు. This is X NOR operation, so which is inversion of XOR operation. Okay, and this will be the truth table here. Okay, so the conclusions will be like this. So when two inputs are similar, output is high. Okay, so when two inputs are not similar, dissimilar, output is low. Okay. So actually XNOR symbol will be like this. It is not mentioned here, but you take the XNOR symbol. So XNOR symbol will be like this. So dot with a circle. Okay. So XNOR symbol is dot with a circle is XNOR. Okay. So F is equal to XNOR Y is written like this. So XOR is plus with a circle. So here it is a dot with a circle. Okay, and F is equal to XY plus X bar Y bar. Okay, F is equal to XY plus X bar Y bar. Okay, so clear. So you should be perfect with this all the symbols. Okay, you should be perfect with all the symbols, all the truth tables, all the equations. Okay, so now I'll explain this equations allowed. So from the truth table, I'll let you know. Okay, so we'll start from this exclusive NOR gate only. Okay, so are you following?
Yes, sir.
Yeah. Okay. So we'll see how this equation comes out of this truth table. So truth table in equations allowed. So please be attentive. So don't. I think only I am getting responses from only a few people, but please be attentive because the coming classes highly depends on these logic gates and all. Each and every topic is important for this class. Okay, each and every topic.
Okay, sir.
Conversion or whether it is anything. So each and every topic is important. Okay, so whatever the class I'm taking, each and every class is important. In each and every topic which I'm discussing is important because everything is interrelated to the next topic. Right. So now we'll see how we get this equation. So see the truth tables here. Okay. So see the truth tables. Okay. So after seeing the truth table, let me know what are the outputs which are equal to 1. So outputs A1 on ikkada. So which are the outputs which are equal to 1? So this is 1 and this is equal to 1. Okay, so these are the outputs which are equal to 1. Okay, so I have to consider these inputs which are responsible for output of 1. So for the final sum here, final equation key, I have to consider these inputs. Okay, so what are these inputs here? X is equal to 0, Y is equal to 0, X is equal to 1, Y is equal to 1. So these inputs should be in the final equation here. Okay, and coming to the equations here, so 0 means it is a complement of X. Okay, and if it is 1, it is a normal form of X. Okay, so if it is 0, it is X bar. Okay, and if it is 1, it is X here. And in similar case for Y also, if it is 0, it is Y, and if it is 1, it is Y. 0 it is Y bar, and 1 it is Y here. Okay, so now tell me the inputs here. So check the outputs once. So outputs A1 I1 manaki. So F is equal to 1 for these inputs. Okay, F is equal to 1 for these inputs. Okay, so what I have to do here is, so F is equal to, and I have to add those inputs, so which are which makes the output as 1. Okay, so I have to add these two inputs here, that is x bar, y bar plus, and these two inputs, which is called as x and y. Okay, f is equal to x bar, y bar plus xy. Okay, so that is the inversion of x exclusor of y, so whole bar, or it is also equal to x exclusor. So I can put a dot here and I can put a circle, and this is equal to y here. Okay, so this is how we had to write the equations from the truth table. So truth tables, what we had to check initially is, so check the values, I mean check the output, which is equal to 1. So we had to separate the outputs, we had to add the outputs, so which are equal to 1 here. Okay, so we had to add the outputs which are equal to 1. So we have the outputs, this has 1 and this has 1. Okay, and these two are equal to 1 here, and we have to add the inputs which are responsible for making this output as 1. Okay, so we have to take the product of these two inputs, so that is x bar, y bar plus these two product of these two inputs, that is xy. Okay, and that both should be added here. So that is how we get this equation. That is how we get this equation. Clear?
Yeah, sir.
Yes, sir.
Yeah. So I mean, I'm telling the different ways. ఒక ట్రూత్ టేబుల్ ని, ఒక లాజిక్ గేట్ ని మనం ఎలా చూడొచ్చు, ఎలా అర్థం చేసుకోవాలి. So I'm telling all the ways to understand this truth tables, to logic gates, everything. Okay. So understand a truth table, understand a logic gate, understand the equation in every possible way. Okay. Next we'll see the XOR gate. We'll see the XOR gate. Okay, so what I'll check here is I'll draw the truth table first. Okay, so inputs are x, y, and f. Okay, so truth table will be like this: 0, 0, 0. Tell me the truth tables of XOR gate. So 0, 1, 0, 1. It's a 1.
1, sir.
Yeah, 1,
1 0 1 0
1 1
and
1
1. It's a 0. So this is a truth table of XOR gate. Okay, so what we have to identify here, we have to identify the values of f. So f ekkada 1 undi, so f is 1 for, so f is 1 for these two inputs, so these two, so this one and this one. Okay, we have to add these two here, we have to add the product of these two. So f is equal to, so 1 దేనికి అవుతుంది, so దీనికి అవుతుంది. So 0 1, so what is 0 1? It is x bar y plus, and for 1 0
plus
plus xy bar.
x plus y bar. xy bar.
Yeah, xy bar. Okay, so I'll let you know. So ఎందుకు మనము ఇన్పుట్స్ ని మల్టిప్లై మాత్రమే చేస్తాము అంటే దానికి ఒక రీజన్ ఉంది, తర్వాత డిస్కస్ చేద్దాం నెక్స్ట్ క్లాస్ లో. ఓకే, so this is called as sum of the products. So these two are the products here. Okay, x bar y and xy bar, and I'm adding these products here. Okay, this is called as sum of the products, which will be discussed in the next classes. Okay, but this is how we got the equation here. To check the truth table, so check the truth table, check the output column, so check the outputs which are equal to 1. So multiply those inputs and add those inputs which are making the output as 1. Clear?
Yes, sir.
Okay, so that is
Yes,
equal,
sir.
this operation is equal to x exclusor of y. So this is the exclusor operation. Clear?
Yes, sir.
Yes, sir.
NAND operation. So I'll take the NAND operation. So NAND operation. Tell me the truth table for this NAND gate. So XY. So it is opposite of AND gate. Okay. So first of all, write this
0 0 1
0 0. It is a 1
1
and
0 1
1 1
1
0
0
1 and 1
1
1
1 0
0. So this is the property of an AND gate here. Okay. This is a property of the NAND gate. Okay. So how to draw this equation? So to draw the equation. So normal gante two ways here. One way is inversion of AND gate. So inversion of AND gate ante. So AND gate emostundi manaku. So AND gate is multiplication operation. Okay. So AND gate is multiplication operation and inversion of that. So normal gate. So this is a simple way. Okay. And we can write it as X bar plus Y bar. So that is a simple way where inversion of the AND gate here. AND gate is nothing but used for multiplication. So multiplication is XY here. Okay, so XY whole bar is equal to X bar plus Y bar. So this is what we get. So if I want to go for using the truth table, so truth table use cheyalante. So what I have to do? I have to check all the ones here. Right? I have to check all the ones. And I have to do the minimization based on the theorems we have. Okay. So F is equal to so which is X bar Y bar plus, because I'm taking the ones here. Okay, X bar Y bar plus X bar Y plus X Y bar. Okay, so there is a thing here. So what is that I can do here? So
X bar Y bar common of X bar plus Y bar.
Okay. So first of all, I'll take X bar as common. So X bar common తీసుకుంటే. So what is the thing I'll get here? So X bar common తీసుకుంటే ఏమవుతుంది? Y bar plus Y Y, yeah. Plus we have X by bar, X Y bar. Okay. So what is Y plus Y bar? So what is Y plus Y bar? It is equal to 1. Okay.
1
into Y plus Y bar is equal to 1 plus, okay, so XY bar. Okay, so XY bar ikkada em vastundi common name teesukochu manamu. So X plus X by Y. So we have the theorem there. So we have the theorem called as absorption theorem. Okay, I think I noted that. So wait a minute, I'll show you. X plus X bar plus XY. So that is the thing, right? This is X plus XY. Yeah. So we can go for X plus YZ. Okay. So what is using distributive law? So using distributive law, what is X plus YZ? X plus YZ and X plus Y into X plus Y into X plus Z. So that is X bar plus X, okay, into X bar plus
Y bar.
plus Y bar. Okay, so X plus X bar is equal to 1 here. So totally what we'll get here? So you'll get it as X bar plus Y bar. So this is how we can prove. So generally equations, truth table batti ila vastundi, but this is a simple method. So what we can do here is AND gate is, so what is AND gate here? So AND gate is a multiplication of two inputs here and the complement of this, and using De Morgan's law, this is the output we'll get here. But using minimizations, we have to follow all these theorems and all those things. Okay, clear?
Yeah, sir.
Okay, yeah, because this is using the truth table also, we'll get the same answers only, but you have to work on that. Okay, for some things it's simple, for few things it's complicated, but if you understand this all these theorems and all, so it will be very easy. Okay,
Okay, sir.
and we'll start with AND gate. AND gate, so which is a very simple one. So AND gate, so xy is equal to xy and f. Okay, so truth table is 0 0, output is 0 0 1, output is 0. So 1 0, the output is 0. So 1 1, the output is equal to 1. So using this truth table, so f is equal to, so I have to check only for the output of 1 here. So f is equal to xy, because it's very clear. Okay.
Yeah, sir.
Okay, and so OR gate also the same thing. XY, but OR gate we have to go for minimizations. So minimization, because we will get 3 ones there. Okay, so 0 0, we'll get a 0. 0 1, we'll get a 1. 1 0,
1 0 1
1 1.
1 1 0.
Sorry, 1 1 1. Yeah, this is OR gate, right? Yeah. Okay, and F normally is
equal to x plus y.
x plus y. Because it is a perform plus operation of 2 inputs here. Okay, but if you want to prove this, so just you can take this as assignment here. So prove this as x bar y plus x y bar plus xy. You can prove this. So which is taken as common here? So x bar
X, sir.
y plus x is taken as common here. Okay, so it is y plus y bar. Okay, so y plus y bar is equal to 1. So what we'll get here? X bar y plus x here. Okay, x bar y plus x. So we can write this as x plus yz, right? Okay, so equation 11.
Sir.
So this is x plus x bar okay, it can be written as x plus x bar y. So this is x plus yz. So what is x plus yz? X plus y into x plus z.
X plus y to X plus Z.
Yeah. So x plus y into x plus z is nothing but, so it is x plus x bar
Into X plus Y.
x plus
X bar.
x bar into
X plus Y.
x plus y. Okay, as x plus x bar is equal to 1. Okay, so the output is like x plus y. Okay, so this is how we have to, when we are given the truth table. So if you are given the truth table, so if you are given the truth table and you are asked like this, so derive the Boolean expression for Boolean function for the given truth table. Okay, so మీకు ట్రూత్ టేబుల్ ఇచ్చారు, ఆ ట్రూత్ టేబుల్ ఇచ్చిన తర్వాత సో మిమ్మల్ని అడగచ్చు లైక్ బూలియన్ ఎక్స్ప్రెషన్ కావాలి, దీనికి బూలియన్ ఫంక్షన్ కావాలి. ఓకే, దెన్ వాట్ యూ హావ్ టు చెక్? సో చెక్ ద అవుట్పుట్స్ విచ్ ఆర్ ఈక్వల్ టు 1 అండ్ జస్ట్ యాడ్ దోస్ ఇన్పుట్స్. ఓకే, సో ఇన్పుట్స్ ఏవైతే రెస్పాన్సిబుల్ ఉన్నాయో ఆ ఇన్పుట్స్ మల్టిప్లై చేసి మొత్తం అన్నిటిని యాడ్ చేయాలి. సో ద వే వి ఫాలోడ్ రైట్ నౌ. క్లియర్?
Okay.
Okay, so remember all the logic gates and their symbols, just know the symbols. Okay, and afterwards know their truth tables and know their equations. Okay, and know their properties. Aim properties. What XOR gate చెప్పాను, XOR gate property is like x exclusive of 0 is x exclusive of 1 is x bar. So that properties, that kind of properties you have to definitely understand. Okay, and when I come to the properties of AND gate, so what we can check here with in case of the AND gate, so ANDing with 0 is 0 irrespective of the input, ANDing with x and 1 is x here, x and 1 is x, so whatever the input we give, that will be the output in case of the AND gate here, and x and OR operation of 0 will get x here, and XOR and OR operation of 1 will get a 1. So OR operation with 1 will always definitely get a result of 1, and OR operation with 0, so whatever the input we give, that will be the output. Okay, so you have to remember the properties of each and every things here. Okay, you have to remember the properties of each and every thing. Okay, so this is the logic gates here. So this is the logic gates in detail. Okay, so what I'll do, I'll stop it for here. So what I want you to do here is, so learn all the functions of the logic gates, learn more about the logic gates. Okay, so study more about the logic gates. Okay, so next class we'll see the Boolean function, how to implement this Boolean function using this logic gates. Okay, so we are going to the next topics are really very important. Okay, so what are the topics we are going to discuss, and I'll tell you not to miss any classes here, because these topics are very important. As a EC engineer, as a electronics and communication engineer, this is the core subject, and this subject is for all, each and every department will study this subject, all the core branches like the CSC and EEE. So this subject is very important. Okay, so your competitive exams or your computers, or whatever the technologies we use, this subject understanding is very important. Okay, so I'm stopping here because I want you to understand the logic gates in different ways. So the truth tables, the Boolean functions, the Boolean equations, how the Boolean equations we got here, and what is the truth table, how to see the truth table, how to draw the conclusions from each and every logic gate, and what is the property of each and every logic gate. Okay, that you have to understand and study more about the logic gates today. Right? Clear?
Yes, sir.
Okay.
Yes, sir.
So please attend, and please attend all the classes. Because you are staying idle. So don't be passive listeners. Just be active listeners. So don't come and just put it on mute and just don't go away. Okay. But just listen. Each and everyone, just try to listen, and yeah. See you tomorrow. Okay.
Thank you, sir.
Okay, so drop your attendance and study well, and I'll be sharing this textbook right now. So in your group, if you don't have, if you have not downloaded that, so I'll be sharing this. So within a matter of minutes, I'll be sharing this. So Mirenia Sarante, you just refer the textbook also if you don't have any soft copy, if you have not downloaded that. Okay, I'm sharing in your WhatsApp group. Yeah, so have a nice day, and see you tomorrow. Yeah. So I've shared that. You can check. Yeah, see you.